Hello students, in last lecture we have learned about Mendeleev's periodic table and his law. At the time of Mendeleev, the inner discovery or the interior of the atom, when Mendeleev put forth the periodic table, was not known to the scientific world, and therefore he stated that the properties of elements are a periodic function of their atomic masses, and the atomic number in the Mendeleev's periodic table are only used as serial number of those elements. But when in 1913 a English scientist, Henry Moseley, demonstrated an experiment by using X-ray tube, and he proved that the atomic number, which is denoted by Z, corresponds to the number of protons in the nucleus of the atom of that element. And this reveals that atomic number is more fundamental property of an element than atomic mass, and therefore he stated a new law which is also known as modern periodic law, as properties of the element are a periodic function of their atomic numbers. And by using this law, he arranged all the known elements in a tabular form, which is also known as modern periodic table. Let us see how modern periodic table is arranged and what is the structure of this modern periodic table. Here you will see a picture of modern periodic table. Here clearly it is seen in the picture that elements from hydrogen to organization, that is from atomic number 1 to atomic number 118, all the 18 elements are arranged in this periodic table. Now let us study this modern periodic table. Here you will see each element has particular place which is denoted by a square or box. Each element is placed in separate boxes, and in such a way there are total 118 boxes. Then you will see there are total 7 horizontal lines or rows. There are 7 horizontal rows which are known as periods. That means period number 1 from hydrogen to helium, then period number 2, this one, then period number 3, 4, 5, then 6 and 7. There are total 7 horizontal rows which are known as periods, and 18 you will see here from number 1 2, 3, 4 and such a manner up to 18. There are 18 vertical columns here from hydrogen to francium, and here from helium, neon and forward there are total 18 vertical columns, and these columns are known as groups. That means modern periodic table consists of 7 periods and 18 groups. You can see there is a difference in color, that is Here you will see these two groups are denoted as S block. Then from that means group 1 and group 2, first and second group is considered or is named as S block. Then group 3rd to 12 is considered or named as D block. Then group 13 to group 18 is considered as P block, and the elements which are kept below the periodic table, which are known as lanthanide series and actinide series, all these elements are kept at the bottom of periodic table and which are placed in or named as F block elements. Now you will see here that all the modern periodic table is divided into 4 blocks, that is S block, P block, D block and F block. Then why it is again divided into 4 blocks? This is due to their similarity in electronic configuration, because as it is considered that electronic configuration decides the property of an element, and therefore as there is a similarity in electronic configuration, there must be similarity in properties, and hence they are kept together, and depending on electronic configuration they are separated by 4 blocks. Then here at the right side of this periodic table you will see one zigzag line. This zigzag line separates two different types of elements, that is these all elements which are placed at the left side of this zigzag line are called metals, and all these elements at the right side are non-metals. That means this zigzag line separates metals and non-metals. Along this zigzag line you will see boron, silicon, germanium, arsenic, antimony, tellurium. All these elements are nothing but metalloids. That means they show properties of metals as well as some properties of non-metals, and therefore they are known as metalloids. Now you can see in modern periodic table elements are separated by 4 blocks, as well as there is separation between metals and non-metals. Now here we will see how electronic configuration is considered to arrange the elements. Here you will clearly see that hydrogen has electronic configuration or distribution of electron as 1, as its atomic number is 1, helium 2, then lithium 2, 1, then beryllium 2, 2, and as we move from left to right you will see number of shells in lithium, just two shells are there, and as we move from left to right you will see the number of electron goes on adding in outer shell of that atom. Here you will see lithium has 1 electron in its outer shell, beryllium has 2 electrons, that means there is increase in 1 electron, and in this manner up to neon we will see outermost orbit contains 8 electrons. Now, after neon, that means neon has atomic number 10. That means after neon, the next element which has atomic number 11 must add electron in outermost shell. But here you will see the electrons in outermost shell, the number of electron is 8, and you know that maximum number of electrons present in outermost shell is 8, and therefore next shell gets added, and that extra electron, that means 11th electrons, gets added in third shell. Now here you can see the shell numbers, that means number of shells present in that atom of an element, is nothing but period number of that element. Here you will see hydrogen and helium has just only one shell, therefore they are in first period. Then from lithium to neon, every element has two shells, therefore they are placed in second period. And from sodium to argon, all these elements has three shells, therefore they are placed in third shell. And like that, as we move down the groups, we will notice that shells goes on adding. That means in fourth period, all the elements will have 4 shells. In fifth period, all the elements will have 5 shells, and in such a way, in seventh period, all the elements which are placed in this seventh period will have shell number 7. That means they have 7 shells in that atom. Now, by knowing the electronic configuration, you can clearly state number of shells, and by knowing the number of shell, you can identify that element is placed in which period. Now, to know the maximum capacity of that shell, we will see one formula to calculate the electron capacity of given shell. Here that formula is 2n square, where n is shell number which are given from 1 to 4. That means shell k will have n is equal to 1, L will have n is equal to 2, M will have n is equal to 3, and n will have n is equal to 4. And if you put the value of n of that respective shell, we will get the electron capacity. For example, if we consider shell k, here you will see 2 into 1 square, there is 1 means value of n. We will get 2 into 1 square is 1, that means 2 into 1 is 2. Similarly, if L shell is considered, we will see 2 into 2 square. Here 2 is value of n, 2 square is 4, and 4 into 2 is 8. And in such a way, we find that electron capacity of K shell is 2, L shell is 8, M have electron capacity 18, and N has electron capacity 32. Now we have seen the structure of modern periodic table, which was arranged by Henry Moseley. Now these all 118 elements are part of our life, and we will just see one picture how these elements are part of our life. You will see in this picture from hydrogen, sun and star consist of hydrogen gas. Helium, balloons are there, and in such a way you will find all the objects which we use day to day are consist of or are manufactured by using all these elements. Therefore, these elements are very important part of our life, and hence we have to study all these elements very carefully. Now let's move towards next section of this chapter, that's trends in periodic tables. Trends mean there is some gradation in the properties of elements. Now, by using this modern periodic table, let us study the trends of properties or gradation in properties of some elements. Here we will consider three trends, that is valency, atomic size and metallic and non-metallic property of element. Let us go through one by one. First is valency. Here you will see as we move from left to right, electrons goes on adding in outermost shell. Let us take the example of third period. Let us we move from sodium to argon. We will see here that electrons goes on added in outermost shell, and its electronic configuration will like this: 2, 8, 1, 2, 8, 2, and till argon it will be 2, 8, 8. Now here you will see as electrons goes on adding in outermost shell, the number of valence electrons changes. Number of valence electron means the electron present in outermost orbit, and as valence electron number goes on changing, eventually that elements will show different electronic configuration, and depending on this electronic configuration its valency will also change. Now let us see how valency changes. In sodium, outermost electron is 1, therefore it can easily donate this 1 electron. That means the electron which can take part in chemical reaction, the number will be 1, therefore valency of sodium will be 1. Here magnesium will donate 2 electrons to complete its octet or to attain its stable state. That means with outermost electron 8 it can donate 2 electrons, hence magnesium will have valency 2. In aluminium it can donate 3 electrons, while silicon can donate 4 electrons as well as it can receive 4 electrons, and therefore it has valency 4. Now let us take an example of phosphorus. Phosphorus has 5 electrons in its outermost orbit. That means to attain stable electronic configuration, that means 8 electrons in outermost orbit, it has to donate 5 electrons or it can receive 3 electrons from other atom, and therefore we can clearly see that it is very easier to receive 3 electrons than to donate 5 electrons, because energy to donate 5 electrons will be more than to receive 3 electrons. Therefore, phosphorus can receive 3 electrons and hence its valency is 3. Similarly, as phosphorus, sulfur can able to receive 2 electrons to attain stable electronic configuration, and therefore sulfur will have valency 2. Chlorine can receive 1 electron, therefore it will show the valency 1. Now, in the case of argon, it has already 8 electrons in its outermost orbit, therefore it will not receive or donate any number of electrons, therefore it will remain as it is in any chemical reaction. Therefore, this element is known as inert gases or inert element or noble element. They does not take part in chemical reactions and therefore they have valency 0, as they do not give or donate any electron or receive any electron. Hence, here we can see as we move from left to right, valency goes on changing. That means its valency changes from 1 to 4 and then again decrease from 4 to 0 along the periods. Now, what will happen down the group? Here you will see all the elements present in one group has same number of electrons in outermost orbit, and as there are same number of electrons in outermost orbit, you can clearly see that they will show similar valency. That means down the group valency does not changes, but across the period valency goes on changing in modern periodic table. Now next trend is atomic size. Atomic size means what? The distance from center of nucleus, that means center of atom, which is nucleus, to the outermost electron present in that atom. Suppose we take the example of this potassium. Here we will notice that this is center of that atom, and from this center till this outermost electron, the distance is known as atomic radius. Radius is nothing but atomic size. Now let us take same table. Here you can see across the period, here number of electrons in outermost orbit goes on increasing. Electrons will have which charge? That is negative charge. And atomic nucleus consists of proton and neutron. Neutron does not have any charge, but proton have positive charge, and therefore there is attraction between positively charged proton and these electrons, and therefore there will be attraction between positively charged proton and electron present in outermost orbit, as they have opposite charges. And here you can see if number of electron goes on increasing, negative charge will also goes on increasing, and as the number of electron goes on increasing, similarly there must be increasing number of proton, and therefore positive charge also goes on increasing, and as there is increasing both the positive and negative charge, the size of atom will go on decreasing, because there is more attraction between outermost electron and nucleus, and therefore across the period, as we move from left to right, the number of electrons goes on increasing, and therefore there is attraction or attractive forces are also goes on increasing, and therefore there will be decrease in radius of element. That means sodium will have more atomic size than chlorine. That means sodium is bigger element or bigger atom, and chlorine is smaller atom than sodium. Now down the group, here you will see, as we move down the group, there is increase in shell. That means shells goes on increasing, and eventually as the shells goes on increasing, we can see distance between nucleus and outermost electron will also goes on increasing, and this distance is nothing but atomic size, and therefore as we move down the group, there is increase in atomic radius, that means atomic size. Third trend is metallic character. Metallic character is nothing but capacity of donating electrons. That means the elements which has more capacity to donate, or which can easily donate the electron, is more metallic. Here we will see the example of sodium. Sodium has one electron in its outermost shell, and let us take an example of aluminium. Aluminium has 3 electrons. Then which element can easily donate the electrons? Clearly we can see sodium can donate electrons very easily than aluminium, because to donate 1 electron is easier than to donate 3 electrons. Therefore sodium will show more metallic character than aluminium. Now let us take the example of chlorine. Chlorine has 7 electrons in its outermost orbit. That means it cannot donate 7 electrons, but it can receive 1 electron. That means it can gain 1 electron, and gaining means non-metallic character, because non-metal gains electrons and metals donate electrons. Therefore here you can say that metallic character goes on decreasing from left to right across the period. That means sodium will have more metallic character than other metals in that period. And of course all the non-metals are placed in right side of this periodic table, and hence we can say all the non-metals are at right side and metals are at left side. And from this information you can also state that metallic characters goes on decreasing from left to right across the period. Now let us see down the group what happens. As we move down the group, here you can see shells goes on increasing. As we move down the group, the number of shells goes on increasing. That means distance between nucleus and outermost electron goes on increasing, and as distance increases, it is easier to donate the electrons, and therefore as we move down the group, metallic character goes on increasing. In this table here you can easily understand the metallic character of the elements. Here you will see the decrease in atomic radius as we move from left to right, increase in electronegativity. Electronegativity goes on increasing. That means non-metallic character goes on increasing, and decreasing electropositivity, and therefore metallic character goes on decreasing. Electronegativity is related with non-metallic character and electropositivity is related with metallic character. Then down the group there is increase in atomic radius, then decrease in electronegativity, and therefore non-metallic character also goes on decreasing, and increasing electropositivity, that means metallic character goes on increasing down the group. Besides these trends, there is gradation in halogen family. In group 17, the member of halogen family are placed, and these are also denoted by a general formula X2, and this gradation observed in the physical state down the group. Let us see where the halogens are placed in modern periodic table. Here you will see in group 17 the elements from fluorine to iodine are placed in group 17, and these are known as halogen, and there is a gradation in their physical state, that is fluorine and chlorine are gaseous elements, bromine is in liquid form, and iodine is found in crystalline, that means in solid form. That means there is a gradation from gas, liquid and solid. I hope you have understood all the topics which we have covered in this lecture. Let us take a review what we have learned. We have first seen the classification of elements depending on its atomic number. That means according to law of Henry Moseley's modern law of periodic table. That law was the properties of element are the periodic function of atomic number of that element. Then we have learned how elements are arranged in modern periodic table. We have learned the structure of that periodic table. Then there are some trends in periodic table which are atomic size, valency and metallic and non-metallic characters. Then we also learn that there is gradation of properties in halogen family. I hope you understood all these points, and we have covered this topic, periodic classification of elements, in these two lectures. Thank you.